Okay, so first we're going to talk about what is an annuity. Okay, an annuity is a series of equal payments. Okay, so that's the important equal payments paid into or out of an account at regular intervals. Okay, so when we're talking about this, we're talking about one of two things, kind of like a loan. So that's like a payment against an amount that you owe, or we can talk about investments. And if you think about like a car loan, you could pay a car loan once a month. Okay, so that would be the regular interval. An investment, you could pay into an investment weekly, so once a week, or once a month, or once a year. Okay, again, regular interval. Okay, when we talk about ordinary simple annuity, this is just a specific kind of annuity where payments are made at the end of each compounding period. That's usually what we're talking about for like the scope of this course. Okay, so the formula for the amount, so the amount of an annuity or like the future value, so what maybe an investment is worth, okay, what it's worth in the future, what it's worth in the future, is the sum of the regular deposits plus interest. Okay, what this means is that when you put in, say, $100 weekly, so it's at the end of this week you put in $100. Well, that's going to collect interest right away. And then next week you're going to put in $100. Well, that's going to collect interest starting next week. The following week, $100. That's going to not have like the first 2 weeks of interest, but then the interest afterwards, right? So it's like the regular deposit, whatever you put in, plus the interest that that amount gains. Okay, so the amount is going to be equal to your regular payments times, this is basically the interest rate, so 1 plus I. And when we talk about I, what we want to do is we always want to divide I by the number of compounding periods. Okay, we always want to divide it by n, and I'll show you that in examples. When we talk about compounding periods, I'm just going to kind of skip down to here. I use the example as weekly, which is 52. Okay, but it could also be quarterly, so once every 3 months, that's common. Bi-weekly would be kind of like your paychecks at work, very common to get paid bi-weekly every 2 weeks. Okay, and then you can read over the rest of these. Annually is once a year, monthly is 12 times a year, once a month, semi-annually twice a year, semi-monthly, this is twice a month, 2 times per month. Okay, and just remember semi-annually and bi-weekly are different because bi-weekly, if you think about the number of weeks in a year, which is 52, that would make you get 26 rather than 24. And we talked about this, when you get paid 26 times a year, twice a year in that month, you're going to get paid 3 times, right? Because there's that like 2 extra paychecks. Okay, and then daily 365. Okay, so what we have to do is we have to divide the interest by the number of compounding periods. Okay, because you're not going to get paid the full interest. I'm going to use quarterly as the example. You're not going to get paid, say, 4%, and then 4%, then 4%, then 4%, 4 times. What's going to end up happening is that you're going to get paid 1% 4 times, which is going to add up to 4%. Okay, so you have to divide it out so that it's only the interest accumulated during that period. Okay, and then to the exponent n minus 1 divided by I. Again, I is going to be divided by n. We're going to go through that. Ordinary simple annuity. Okay, so Sammy recently started a full-time job and wants to start saving for a down payment on a house. Okay, so all we can take from this so far is that he just wants to start saving. Okay, it doesn't really matter what he's saving for. So this is putting money into an account. Okay, she decides to save $450 at the end of each month. Okay, the end just comes from the ordinary simple annuity. If you remember, that's just when you pay in payments at the end of a compounding period. Okay, so if it says the end of each month, that means that our compounding period is monthly. Okay, she wants to save for 1.5 years. If you think about 1.5 in months, it would be like 1.5 times 12 months a year, which is 18. So like the total of 18 months. Okay, so keep that in mind. Into an annuity that earns 6% per year compounded monthly. So again, it actually tells you that now it's monthly. Okay, so I made a chart for you guys. R is the normal payment. So if you think about R, we're thinking about $450, right? She's putting $450 into that account. Now we have the interest rate of 6%, but the thing is she's not going to get that every single month. That's going to be divided into the number of payments. So when you divide decimal 0.6 divided by 12, you get 0.005. 1, 2, 3. Yep. Okay. So that's the interest that she's going to get paid out every month. And then the number of compounding periods. So that would be like our 1.5 times 12. So the number of compounding periods, she's actually going to be paid out 18 times. Okay, so let's go over here. How much does Sammy have at the end of 1.5 years? So this is actually asking for the amount. Okay, so the amount is $450. Okay, 1 plus I, so it's going to be 1 plus 0.005 raised to the exponent. How many times is she paid out? Well, 18 times. Oops. Minus 1. Okay, all over I, so I is here, 0.005. Okay, if you put this into our calculators, what we get is, I'll do the 450. What you get here is 0.0939928. Oh, and I should box this. My tablet was being messy. I write over 0.005. Okay, so if you multiply the top, we get 42.268, and then divide that out. What we get is 8453.60. Okay, so at the end of 1.5 years, she has 8453 and 60 cents. Okay, now how much does she actually invest? So here's the thing. She invests $450 and she invests this 18 times. So that's like a simple calculation. She invests $8,100. Okay, and then how much interest does she earn? Well, if she, let's move this down here. So I have room here. Okay, if she has at the end of her investment 8453.60, and she only actually put in $8,100, then that means that it grew from 81 up until 8453. So the actual difference is 353.60. Okay, and then you can make a therefore statement. Okay, therefore she invests $8,100, grows to 8453, earning go $353.60 interest. A little jam down there. That's it. She turned 16 and she wants to save, so again, another saving example, to go to college at the age of 20. So if we think about this is 4 years. Okay, she decides to save $100, deposited at the end. Okay, end just means simple, ordinary annuity of each week. That would be the compounding period, weekly, into an annuity that earns 5.2% per year, compounded weekly. Okay, so I'm going to skip this for a second. The regular payment, she's paying $100 into an account. It's earning 5.2 per year, but because it's paid out weekly, we divide it by 52 because there are 52 weeks in a year. Okay, so it's 0.001. And then she's going to save weekly for 4 years. So 4 years times 52 weeks a year. What do we get? $208. Okay, good. 16 to 20. All right. So A, how much does Emily have at the end of 4 years? Okay, so this is asking for the amount. Okay, so she's putting in $100 weekly. Okay, it's 1 plus 0.001 raised to the exponent n, which is 208, minus 1. And then this is all over I, which is just this number here, 0.001. Okay, so I'm going to put this into my calculator. So 1.001 raised to the exponent 208 minus 1. I get 0.231085. So I get 23.108, 0.001. So I get, she's going to be able to save $23,108.52. Okay, if you're thinking about how much she's actually investing, she's investing $100 208 times. So she's actually investing $20,800. Okay, and see over here, how much interest does she actually earn? So the interest, so here's the thing. So the interest is going to be how much is in the account, $23,108.52, but she only put in $20,800. So that means that this went up 23,852. It went up $2,308.52. Okay, and you can make a therefore statement. She invests $20,800, earns $2,308.52, totaling $23,108.52. Savings question. $1 million for retirement. Okay, he's 30 years old and he plans to retire at 60. Okay, so this is 30 years difference. Okay, from 30 to 60. If you want to formally do that, it's just 60 minus 30. If he pays $2,000 into a quarterly annuity, so $2,000, it's quarterly, so that's 4 times per year. And he earns 4.44% compounded quarterly. Okay, so 4.44%. Remember, we have to convert that into a decimal. So we divide it by 100. 0.011. And then this is 30 years times 4 times a year. He's going to put this amount of money in 120 times. Okay, does Pat reach his goal? Okay, so essentially what we want to do is we want to find out the amount and then compare it to $1 million. Okay, so the amount is, he's putting in $2,000. he's earning 0.011%, 120 times, okay, and 0.011. So when I calculate that, I get 2,000, 2.7609 over 0.011, and then when you multiply and divide it, I get 5521. I'm just walking you through like the calculations just in case you're making a mistake on your calculator. So I get 497, 461, 74. Okay, so let's compare this. Is this greater than or equal to $1 million? So this is less than $1 million. Okay, so this is the crocodile less than $1 million. Therefore, he does not reach his goal. Okay, B, how much does he actually invest? Well, he put in $2,000 and he put that in 120 times. So he actually invests $240,000. Okay, and how much interest does he earn? Well, he earns 497, 461, 74 minus what he actually put in. So this is quite interesting. He earns 257, 461. That's a lot of interest. That's more than double the amount of what he actually invested. Okay, so that's the amount of interest that he put in. And you can do another therefore statement.